Welcome to lecture for 7.2. We're going to continue looking at inverse trig functions. Some of our objectives are to define the inverse secant, cosecant, and cotangent functions, find the value of inverse secant, cosecant, and cotangent functions, find the exact value of composite functions involving inverse trig functions, and write a trig expression as an algebraic expression. So, our definitions for the inverses of our secant, cosecant, and cotangent and the values of these things are all found in the text, which you should have completed with your guided notes. So what I'm going to do is jump to our third objective, finding exact values of composite functions. And our first composite function is cosine of sine inverse of 1/2. So the first thing that we want to do is let theta be that sine inverse of 1/2. So that way we're essentially rewriting this as cosine of theta. Now, if theta equals sine inverse of 1/2, and we take the sine of both sides, we'll have sine theta equals 1/2. And we talked about the inverses of trig functions in our last lecture. Okay, so sine theta of 1/2, the interval we're looking at for sine is negative pi over 2 to positive pi over 2. And in this interval, where does sine theta equal 1/2? Well, referencing our unit circle, we see that sine theta is 1/2 at pi over 6. So now this is what we said was inside of our cosine. So we have cosine theta, which we found to be pi over 6, so cosine of pi over 6, and the cosine value at pi over 6 is radical 3 over 2. So we break this down into steps, so that way we can just solve one piece at a time. Our next one is tangent of cosine inverse of radical 2 over 2. So again, let theta equal cosine inverse of radical 2 over 2. Taking cosine of both sides lets us have cosine equal radical 2 over 2. And where does cosine equal radical 2 over 2? Well, that would be at pi over 4. So now we had tangent of theta, which we found to be pi over 4. And our tangent value at pi over 4 is 1. Okay, now we've got secant of cosine inverse of radical 3 over 2. We're going to start the same way. Let theta equal cosine inverse of radical 3 over 2. Taking cosine of both sides, we have cosine theta equals radical 3 over 2. And where does cosine equal radical 3 over 2? That would be at pi over 6. And so we had secant of theta, which we found theta to be pi over 6. And secant of pi over 6. Well, what is secant? We can rewrite this to kind of understand what's happening. Secant is 1 over cosine. So we're looking for 1 over cosine of pi over 6. It's a lot easier for us to understand cosine of pi over 6. So we have 1 over, and if we find the cosine value at pi over 6, that's radical 3 over 2. And 1 over radical 3 over 2, that just takes the reciprocal. So we have 2 over radical 3. Let's rationalize that denominator. Radical 3 over radical 3, which leaves us with 2 radical 3 over 3. Next we have cosine inverse of cosine of 5 pi over 3. Now our first initial reaction is, oh, we have a cosine inverse and a cosine. Let's just cancel those out. Answer's 5 pi over 3. But what is the interval we're looking at? So what is this allowed to be, right? We're looking between 0 and pi. So this looks like, on our unit circle, 5 pi over 3 is about right here. And our interval from 0 to pi is from here to here. So 5 pi over 3 is out of our interval. We need to find an angle in our interval that would give us a relation that we can use, right? So where do we see this angle being made in our interval from 0 to pi? Well, we see it about here, because we can see that this angle and this angle would give us the same angle. So one thing to note immediately is that 5 pi over 3 is not in the interval, which makes us have to find one that is. In this case, we find that pi over 3 is in our interval, giving us that angle that we're looking for. So let's rewrite it with this angle that is in our interval. We have cosine inverse of cosine of pi over 3, and cosine inverse of cosine are inverses of each other. So we're left with pi over 3. And that's our exact answer. We're leaving it in fraction. We're leaving it in pi. Okay, sine inverse of sine of negative 5 pi over 4. Well, our interval that we're looking at is from negative pi over 2 to pi over 2. That means negative pi over 2 to positive pi over 2 are these values. We see negative 5 pi over 4. So negative 5 pi over 4 would be something like this. Negative 5 pi over 4. So it's outside of our interval because we were only focusing between negative pi over 2 to positive pi over 2. So we need one that's in our interval. If we follow the same angle in our interval, we can find one here at pi over 4. So I'm just going to note here, negative 5 pi over 4 is not in the interval, but pi over 4 is in the interval. So I'm going to rewrite it with the value that is in our interval. Sine inverse of sine pi over 4 and the sine inverse of sine, they cancel each other out. They're inverses of each other, so we're left with pi over 4. Okay. Our last one for this set of examples, sine inverse of cosine of 7 pi over 6. This one, our interval is 0 to pi. It's always important to recognize what's your interval here. That way you know if it's in or out of the interval. So 7 pi over 6, what does that look like? We're going from 0 to pi in this interval, and 7 pi over 6 comes out about right here. So it's just outside of our interval, it's gone past pi. So if we are going to find the same angle being made in our interval, it would be about here, which falls at 5 pi over 6. The note that I would make is 7 pi over 6 is not in the interval. But 5 pi over 6 is. So we'll rewrite it, sine inverse of cosine of 5 pi over 6. What is the value of cosine at 5 pi over 6? So we'll solve that piece first. And the cosine at 5 pi over 6 is negative root 3 over 2. And for our sine inverse, we're looking at negative pi over 2 to positive pi over 2. So this sine inverse of negative root 3 over 2 is like asking theta equals sine inverse of negative root 3 over 2. Remember when we rewrote these things in previous lectures? And so if we take the sine of both sides, we get sine theta equals negative root 3 over 2. And where in our interval is sine theta negative root 3 over 2? Sine is negative root 3 over 2 at negative pi over 3. Okay, next we're going to find exact values of these expressions, and we're going to be using all 6 of our trig functions. And before we begin, I just wanted to give you something to help remember when these trig functions are going to be positive or negative. So if we look at our unit circle, we have our 4 quadrants, and if we go around, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And as you go around in order, one way to remember these, the signs of all of your trig functions is to remember all students take calculus. And this helps us because the A in all tells us all of the functions are positive. So cosine is positive, sine is positive, tangent is positive. All of our functions are positive values. Now, the S in students tells us that sine is positive. Cosine is a negative value and tangent is a negative value. The T in take tells us that tangent is a positive value, but sine is negative and cosine are negative. And the C in calculus tells us cosine is positive, but sine is negative and tangent is negative. So it's a nice reference tool to help remember. It's really easy. All students take calculus as we move around quadrants in order, and we can easily remember which functions are positive and then which are negative. This will come in handy in these next few examples. So we want to find the exact value of secant of tangent inverse of 6/7. So let's start by letting theta equal tangent inverse of 6/7. And if we take the tangent of both sides, we have tangent equals 6/7. And this is between negative pi over 2 to pi over 2. Okay. Now this value of tangent is positive. So we're looking at where is tangent positive 6/7? Where is tangent going to be a positive value? Well, since tangent is greater than 0, it's a positive value, and we are within our interval, right? Our interval is from negative pi over 2 to positive pi over 2. and tangent is a positive value in quadrant 1. So we're working in quadrant 1. Our answer needs to be in quadrant 1. Now, what do we know about tangent? Well, from previous sections, we know that tangent, being 6/7, is also written as y over x, which tells us immediately that our y value is 6 and our x value is 7. Now this tells us the location of our point. So this is telling us that our point on the unit circle is at 7, 6. So let's find that guy. This is 0. So 7.76 is somewhere around here. There's our point, 76. This is the theta created. And using what we know about our triangles that are created by these lines in our unit circle, we know that x squared plus y squared, according to our values, are going to be 7 squared plus 6 squared. And this gives us 85. And this value is our r squared. R being our radius from the center of our unit circle out to that point P. So let's start putting in our values. We started with secant of tangent inverse of 6/7. We turned that into secant theta. And just as a side note, we can remember that secant theta is written as r over x. And using the information about our theta was tangent inverse of 6/7. We found out x, y, and r. We can rewrite this secant theta as r over x, r being square root of 85, because r squared was 85, so if we just want r, we need the square root of it, x being 7. That's our exact value. These problems require a few more steps because now we're looking specifically at a value that's not in radians for us. It's not dealing with that perfect pi over 4 value. We're looking at, okay, this is somewhere in between my big 3, right? We memorized those big 3, and now we're looking at what happens if it falls in between these things. And this is what happens. Okay, let's do another one. Cotangent of sine inverse of negative root 7 over 5. Let's begin by letting theta be our sine inverse of negative root 7 over 5. This tells us that sine theta is negative root 7 over 5. our interval is negative pi over 2 to positive pi over 2. If you haven't remembered this yet, we can bring this with us. Okay, that's fine. So our sine value here is a negative number. So in our interval, we are looking at where is sine negative, since our sine theta is less than 0, we're looking at, you guessed it, quadrant 4. Now, just like before, we're going to use what we know about sine. We can rewrite our sine theta because they gave us negative root 7 over 5. We know sine is also written as y over r, the y value of that point over the radius. This immediately gives us information. Our y value is negative root 7, and our r value is 5. Now you might be asking, how do you know, because that whole fraction was negative, how do I know that the negative sign goes on the root 7 and not on the 5? Well, just think about a few things. We're in quadrant 4, which means my y values are negative. I'm below the x-axis here. So my y value is negative. Another thing, is my r is talking about a radius. So we don't really measure radius with negative. So that's another reason that the negative sign's going on that y. So 2 good reasons. Just give it a little bit, walk yourself through it, talk yourself through it, so that way you are understanding, okay, where would my negative go? Let me take a look here. It goes on my y value because I'm below the x-axis. I wouldn't have a negative radius. Things like that make sense. So, again, we have x squared plus y squared equals r squared based on what we know about triangles happening in our unit circle. This tells me x squared plus 7 equals 25. So x squared equals 18. If I take the square root of these things, then we have x equals 3 root 2, rewriting my square root of 18 in simplest form. So let's write this out. We started with cotangent of sine inverse of negative root 7 over 5. We rewrote this as cotangent of theta. And as a side note, we can recall that cotangent theta we can write as x over y. So based on what we know about our theta being our sine inverse of negative root 7 over 5, we found x, y, and r. So cotangent theta, written as x over y, would give us 3 root 2 over negative root 7. Let's rationalize that. Root 7 over root 7. This gives us negative 3 root 14 over 7. That is our exact value. And then I'm just going to bring him down here for our last one. I'm just going to see if I can get rid of some of these things so it doesn't feel so messy. Okay. Our last one, we have tangent of sine inverse of 2/3. So let's start with let theta be sine inverse of 2/3, which tells me that sine of theta is 2/3. This is from negative pi over 2 to positive pi over 2. And thinking about a positive sign, where would that be in terms of our interval? Sine is positive in quadrant 1. So since sine theta is greater than 0, we are in quadrant 1. And sine theta being 2/3, we can write sine as y over r, which immediately gives us the information that y is 2 and r is 3. So our y value is 2, our radius is 3, which means x squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. X squared equals 5. So x equals root 5. Now we have x, y, and r, so let's get to solving. We have tangent of sine inverse of 2/3, which we rewrote as tangent theta. What can we recall about tangent theta? We can write tangent theta as y over x. And so y is 2, x is radical 5. Rationalize that denominator. Gives us 2 radical 5 over 5. And there we go. Okay, we have one more example to talk about. We want to write cosine of sine inverse u as an algebraic expression containing u. So how can we rewrite this where it's an algebraic expression instead of a trigonometric one? Let's start by letting sine inverse be our theta. So let theta be sine inverse of u. And this tells us that sine theta equals u. This is in the interval negative pi over 2 to positive pi over 2. And our u in this case would be any number. So we can plug in any real number as our u, or as we plug in theta, we would get any number out for u. Okay, so we started with cosine of sine inverse of u which we rewrote as cosine theta. And what do we know about cosine theta? This might be a stretch for some of you, but one thing that we know is that sine squared theta plus cosine squared theta equals 1. And we can derive cosine from this identity. If we want cosine alone, that would be cosine squared equals 1 minus sine squared. And if we take the square root, we are left with just cosine is the square root of 1 minus sine squared. So we're going to use that to rewrite our problem over here of cosine. Cosine can be rewritten as the square root of 1 minus sine squared. So let's do it. Let's rewrite this cosine as 1 minus sine squared theta. Now, why did we do that? It feels like we haven't moved much. Well, we did that because if we remember, we found sine in terms of u. So sine, we can rewrite sine theta as u. Well, that means that sine squared theta is just u squared. So we have the square root of 1 minus u squared. And now we've rewritten it as an algebraic expression containing u. We got rid of all the trig functions. Pretty cool, I'd say. So some really helpful things: reference your unit circle, go through your trig identities that have been given to you so far. We're going to talk a little bit more about them later in this chapter. And get very comfortable with determining the interval that you're in, which is dependent on which trig function you're using.